shut up. Okay. This video is for Kira, or whoever else wants to watch it. We are at the end of the 1-5 notes. And I told you to do this yesterday for homework. Kind of, or at least attempt it, okay? We're going to go through that one step by step, and I'm also going to write off to the side over here what you exactly punch in on your calculator to get to the correct answer, okay? So, we need to first and foremost take that data, and there's 3 columns of data, but that's just so they don't like waste paper and make one big column, right? Okay? So the first thing that we did was, I don't like the x's being such large numbers. So we went ahead and changed the first number to be 0, and then 20, and then 30, and then 40, and blah, 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 right? Okay? Now, you can, if you want to, I'll give you this option, okay? You can, if you want to, do 0, and then 2, and then 3, and then 4, and then 5, and then 6, and then 7, except, let's say you're wanting to find like 1991. If you don't go by tens, that's an issue, right? 1991 would not be a whole number. 9.1. So it's best, it would be like 9.1 or whatever that is, right? Okay, 99.1 is what it would be or something, whatever. 90.1. So that's a problem. No, it is 9.1. I don't know. Anyway, that's a problem. So you need to make sure you go by, you be thinking about numbers that you're going to plug in, okay? So we went 0, 20, 30, 40, blah, 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 okay? We're going to type that into the calculator. And you're going to turn your calculator on. Turn the calculator on. Okay. Go to. I'm going to write this over here. To enter data. To enter data. Here is where you go. To enter data, you go stat, which is the button on your calculator. Stat. And then you go edit. Okay, so on the main screen, after I've hit stat, it's highlighted edit, so I'm just going to press enter. Okay, so I'm going to go stat edit, and it will take me to this table. List 1, list 2, list 3. I'm going to put my stuff in list 1. So I'm going to say list 1 equals the x's, list 2 equals y. Enter numbers. Enter my numbers in. So I'm going to enter them real quick. You do the same. Do all of list 1 first. So 0, 20, 30, etc. If you have not already done so. If you have a Chromebook calculator, if you're using your calculator in your Chromebook, you should just be able to type and hit the enter key. You don't have to hit the buttons on the keypad, right? So 0, 20, 30, 40, 50, 60, 70, 80, 85, 90, and 94 is where it stops. Okay? All right, enter in your stuff in L2. Are those decimals or commas? Can you see? 29.030. You're going to get weird answers if you put that into the comma. Okay? So 29.030.
My calculator is slow. We did it.
I got told that middle straws are literally for you because when you get both of them, I have an apple one. I was like arguing today.
No.
There's nothing wrong with plastic straws. I got it on.
I put all the information in. What do I do now?
There's nothing wrong with just fixes plastic straws if you're using.
All right, here we go. I just entered my data in. If you are waiting and have already typed this in, you need to go back through and make sure you typed everything correct. So take 1 30-second amount of time and look at your numbers and make sure you type them in correctly. I'm going to do the same. All right, go back through and check and make sure all of your stuff is there. Okay? Now, all words. So to enter data. Check. All done. To enter data. Okay, the next thing that I want to do, it asked me to use the linear regression feature of a calculator to find the equation. I want to say, calculator, make me an equation. And it's going to do the thing. So to make equation. Here is where you go. To make the equation.
Why is there a
Check mark, because we've entered the data. I'm checking it off. It is done. To enter the equation, or to make the equation. All of your stuff is in there. You do not have to go back to the main screen. You can go just straight to the next one, right? If it helps you, go back to the main screen. That's fine. Otherwise, I can just hit Stat, and I go over to Calc, and I go down to linear regression. Okay, I'll put that on this paper here. Stat is the button on the main screen. I'm going to put over to Calc, and down to linear regression. And it says AX plus B. Okay, so by doing this, it is telling the calculator, make me a linear equation. What? AX plus B. Yeah, that's what this, I'm just writing out what this thing says. Linear regression, AX plus B. Okay, and you're going to hit enter.
Wait,
Okay.
what do I do after I'm done calculating? Because I was like way behind for you guys because my coworker turned on.
Do exactly what I have up there.
Wait, let's see yours.
To make the equation, hit stat, go over to calc, go down to linear regression. There you go. I'm writing it up there. Writing it up there. Okay, so once you get to this screen, this screen, make sure x equals L1, y equals L2. Make sure that that is true. Down to calc. Calculate. Enter. Down to calculate, hit enter. Be quiet. Down to calculate, hit enter. Down to calculate, hit enter. That's all you need to do. Yes? Yes? Beautiful.
What about your window?
Okay,
Wait,
now
then you
just
get
wait.
numbers and that's not right.
What?
When you get actual numbers, that's not
What do you want?
That's what we want.
right. No, that's not
So what this thing says is, here is my equation in the form of y equals ax plus b. Instead of m, they call it a, which is fine. Then we just plop the numbers in there. So my equation needs to be y equals, a is 1.0, let's go 3 decimals, 1.012. 1.012 x plus, let's go 3 decimals the whole time. 18.331. That is my equation. Yes? What? I don't care. No. 3 decimals. 3 decimals. We want to be really accurate. 3 decimals. Okay? All right. Are we okay with that? Yes. Okay? Here in just a minute, I'll write off to the left side how we graph it and how you change all that stuff. Okay? So we'll go through that also. On this question, it does not actually ask you to make a scatter plot, but I'll show you how to do that for the time that it does ask you for that, okay? So in A, use a linear regression to find an equation that models the data. We did that, right? Then use the equation, listen, use the equation to estimate the number of farm workers in 1975 and in 2000, okay? So I'm going to go over here. 1975, and in 2000. Okay, now, where did 0 start at?
Yeah.
Where did 0, what was 0?
1900.
1900, okay? So basically, if I want to know 1900, I would plug 0 in. If I want to know 1975, what do I plug in? Not 1975, I plug in just 75, right? What do I plug in if I want 2000? 100, right? So I'm not plugging that whole thing in. It depends on what you called your first term. If we called it 0, we have to take the number of years past 1900 and plug that in, okay? So we're going to plug 75 into this equation, and we're going to get an answer out. We're going to plug it in for x. So I'm going to go down here because I'm running out of room. So if I plug 75 in, y equals If x equals 75, y equals whatever. If x equals 100, y equals whatever. We've got to plug those in and solve, okay? Yes? Good? Good? So, take your equation, plug it into your calculator. I'll do it over here. If I go back to the main screen, I can get to this point again. Don't be scared, okay? So, 1.012 times, oh, it's not going to let me do times.
Did you just do
Yes, I did second quit. Delete. Times 75. Close parentheses. Plus 18.331. Right? Yes? Type that all in. Okay, make sure my decimal's all there. Enter. 94.231. Yes?
Yeah. Yeah, girl.
94.231. Okay? Now I'm going to do the same thing. If you want to, you can go back up into the equation and hit enter. So you don't have to retype this whole thing. But the problem is, 100 is 3 digits long and 75 was only 2 digits. Okay? So here's what I'm going to do. I'm going to type 10. And if I type 0 in again, it's going to cover up that parenthesis. I don't want it to do that. So what I'm going to do is I'm going to insert something in there, all right? So the insert button, you see where the delete button is?
Yeah.
Delete button, you're going to insert. So I'm going to go second, insert, and it's going to put a 0 in there. And then my parenthesis stays. Does that make sense?
Wow.
Okay, I'll go through that again. Second, insert. So now it will save you a lot of time because I don't have to retype the thing, yes? Lots of time. Enter. That is 119.531. Okay, what do those numbers mean? What units are they? What do they mean?
In millions.
In millions? Is that what it is?
Yeah.
Yeah, you're in the word.
Number of workers in millions. So in 1975, there was 94 approximately
Wait.
million workers.
You sure that's right?
In 2000, there was 119 million
Why was
workers.
there more workers in 1994 than in 2000? Yeah, look at it. 120.380.119.5.
Because farming went downhill at the start of 2000. Hog
Yeah.
farming went up.
Because this doesn't.
Massive
So that's a really
shift
good
in
question, Colton. That's a really good question. He said 2000 had 119, and he said, wait a minute, we're way over that by 1994. It is because not all these dots fit exactly on a linear function. So our linear equation just approximates those data points, so it's not going to be exact, but that's the only thing we have to go off of. So that's a really good question to ask. Farming is going to go up and down over the years, but in general, it's going to follow this linear trend. Okay, so I'm not to say that this is going to be exactly 119.
Now, will it really keep going up though? Because the way I see it, farming should be going down because people are getting bigger, better equipment, so there's less need for farmers and more farmers.
Right. So that's gonna go along with part C. Okay. So those are our two answers in part A. In part B, according to the model, when will the number of workers be 150 million? Okay. So in that case,
Oh, God.
150 million is going to go in for not X. It's going to go in for Y, right? I want to put 150 in for Y.
2020 is so close. I'm scared.
18.331. And what we're trying to solve for is the years, which is labeled as X, okay? So we're going to unwind this equation, putting 150 in for Y, because that's the output value, and we need to solve for X. So let's take this guy. We're going to subtract the 18.331. Subtract it from 150, 18.331. It's going to be a decimal. Somebody give it to me. Does somebody have it?
131.669.
Okay, 131.669 equals 1.012x. Then we're going to divide both of those, and x is going to be equal to something. 130.108. Okay? Now, what does that mean? That doesn't answer the question, though.
That's the exit.
That's x. According to the model, when will the number of workers be 150 million? Okay? X is 130. Okay? We just got 130.1008, but that doesn't answer the question. The question says when. So what do I say? Year 130.
Yeah.
So then
No,
that would be
no.
130 years after 1970.
100. So Colton said it exactly right. It is 130 years after 1900. Right? 1900 was my year 0. So I'm going to add that 1900, and it is going to be the year 2030, approximately. It is the year 2030 because we add that to 1900. Yes? Yes?
Hey, can we listen to the song Year 3000?
By the Jonas Brothers. Or we can listen to
In the year 3000, New York's underwater.
Okay. I don't know what you're talking about.
Nebraska
It has to
becomes
go on
the
the
biggest
graph.
state.
It's close.
The Hunger Games begins.
Yeah.
All right, in part C.
We're going to become aquatic.
In part C, it's asking the question that Cody was talking about. It says, is a linear function an appropriate one for this one? Cody's like, I think farming's going to eventually level off and we're not going to have as many farmers because we're getting bigger and better equipment, getting more efficient, that type of thing, right? So he thinks that farming is going to maybe level off at some point, okay? Now, part C, though, refers to the R. Okay, on your page where it said R, do you remember how to get to the R on your calculator? It's the same place as making the equation. It's the same place as here. Okay, so let's go back to our stat calc, go down to linear regression, and it's going to spit out your R value, except on mine, my diagnostic is not on. I got to turn that on. Did anybody's not show up?
Wait, what are you doing?
Back to that, stat, calc, linear regression.
I did.
I got to turn my diagnostic on. So second,
Calculate.
catalog. No, it didn't like that. Second, catalog. Go over. Calculate, not, oh. Yeah, calculate. Stat, calc. I got to turn my diagnostic on because for some reason it didn't save. Okay, stats. Here it is. Here it is. If you can't find the R, go under stat, the stat button again. Go over to calculate. Down to linear regression, and your R should be there. And now mine is. Okay? And now mine is there. Okay? So, R is equal to. Then you have to turn your diagnostic on again. Okay? That's what R is, 0.969 approximately.
Wait, is that C?
0.969, that is part C, okay? Now, according to that, it's like basically at 96%. Is a linear function a good function for this model? 9.96 is pretty decent, okay? It's not perfect, like Cody says. It's not perfect, and we don't know how sustainable that is. So maybe it is linear until the year 1994. We don't know anything past that. And then maybe it levels off, okay? So, according to this data, it's a pretty decent linear function. So I'm going to put pretty good. Pretty good. 0.969 is pretty decent. 0.969, pretty good. Okay? We don't know if it's sustainable after that, but we're going to say pretty good for right now. 0.969 is pretty decent, okay? Now, go down to the, wait a second, let's go over here. Go over here to the left side, I'll show you how to graph. How to graph. How to graph, here you go. Put this on the left side, how to graph.
Oh, you're running me out of room.
Sorry. How to graph. We're going to graph this data, okay? So if the data is already in there, just wait a second, listen. If the data is already in there, I'm going to hit the graph button. Yee. Where the heck is my graph? My data is not there. Uh-oh. Uh-oh. Okay? Mine shows nothing. Mine shows nothing because your window is different than mine. That's okay. Okay? Mine shows nothing. We have to fix our window. First, I'm going to say delete out y equals. Okay? Delete out your y equals. Some of you guys might have a random line that is being graphed. A random line that is being graphed. Yes? Go to your y equals and get rid of it. If it is still there, clear it out. Okay? Delete out your y equals because then it's going to want to graph a line. Okay? All right? So you want to delete out your y equals, and then what we're going to do is change your window. Listen.
Wait, what? Where's Y equals?
Just delete out your y equals. So click the y equals button. Click the y equals button here. And if there is an equation up there, get rid of it. Clear it out so that your calculator is not wanting to graph it. Okay? All right, so now we're going to go to window. We're going to change our window. Window is here. Window is here. Window is here. Click on window real quick. We're going to graph this data. Click window. Okay? Now look at our mins. Find
29.
min / max x and y. Okay, and then we're going to put those in appropriately, all right? So our minimum x was
0 to 100.
0. Our maximum x was 94. Let's go from 0 to 100, sure. So I'm going to change this guy. Instead of it being -10, I'm going to change it to be 0 and 100. Yours might not have started at -10 to 10. That's fine. But change it now from 0 to 100, okay? Our y's now. What's the smallest y?
29.
29. What's the largest y?
1.
120. So what are you going to go from? What?
25,
25 to 125? Sure, let's do it.
I just went 29.
That's fine. I don't care. 25 to 125. As long as it's somewhere close to that, okay? 25 to 125. That's what we're going to do on our y scale, okay? Now graph.
Wait. Is it still supposed to be 1 and 0.1?
Change it to 1 and 1. 1 and
I
1.
hate the computer calculator because if it turns off, you have to re-enter everything.
Sorry.
And then press graph.
Okay, now hit graph.
See, that's what happens.
like a
Da,
hundred.
da, 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 da. Where did my points go?
If it turns off, you have to re-enter all
My
the
stat plot's
data.
not on. Second, stat plot. My plots are off. I gotta turn my plots on. Enter. There we go. I gotta turn my plots on. Now, some of you guys, Lacey was asking me this earlier. Listen to this. Lacey was asking me this earlier, and this is gonna answer Brooklyn's question from yesterday, okay? On my stat plot, you go second stat plot to turn your plots on. Okay, you guys' plots should already be on unless you're a computer. Okay, so that might be your problem. Turn your plots back on. Stat plot, turn it on.
How do I turn my plots back?
All right, now
Go
what do you
second y equals.
Wait,
Stat plot, turn it on.
Is
Okay.
that the dim
Now.
match?
No. Yours is a different error, okay?
Go
So
second.
Lacey was asking me this. You can designate how your dots are going to be represented on your graph. So down below here, I have my dot under mark. Under mark, my dot, it looks like an open dot. Okay, that's just so I can see it easier. I can change it from an open dot to a cross or to just a regular dot, okay? Now, Lacey before had hers as just a regular dot, but as soon as the line goes through it, you can't see it anymore. So we left it as an open dot so then I can see the dots after the line goes through. Does that make sense? Okay, so after I've turned my plots on, I'm going to put a little note. May need to turn plots
I
on.
literally got it.
May need to turn plots on. And you do that by second y equals plots on. Yours are already on.
But it's not working.
Plots on, not ons. On, plot
Now
on.
what do
Okay,
you do after
now hit graph. There they are.
Cow. Wait, will you help me with my problem?
There
Yeah.
they are. Okay, good?
Error.
Just wait. I'll help you here in a second. I want to get this video done. If we weren't videotaping, I'd help you, but I don't want to make this like 100 years long video. Okay, there's your plots. Yeah. Now, how do I plot that line over top of it? Do you remember? How do I plot my trend line? I'm gonna do that down here. To plot trend line. How do you plot your trend line? Over top of that.
I'm graphing.
Y equals. I hit my Y equals button. Y equals is here. And I'm going to enter the formula that we had. Enter formula, which is this guy right here. So 1.012x. 1.012. I'm going to put x in there. X is this button right here, right below mode. Plus 18.331. Okay, I go to the y equals button. Plot my trend line. Y equals, that's this button right here. And then I type in this equation that I got.
Oh my god.
Type in that equation that you got. Okay, then what?
I had one dot hit it.
Then you hit graph.
Then hit graph.
Plus. We're gonna make sure you watch it this time.
Then graph. Make sure you watch it this time. There you
It
go.
only hit
So,
one dot.
I know.
It's not fair.
I know, that's not fair. So this kind of answers Colton's question earlier, right? Some of these dots are above the line, some are below the line, okay? That means that the dots don't actually exactly fit along that line, but they're pretty darn close, right?
One does.
Yeah, one dot.
What? One dot fits on there. Okay. So there we go. That's my line. Yes? Yes? So I can gather information from this data. Okay? All right, let's go down to the last example down below. This is just a question, and you will have a question like this on your test. I know for a fact you
It's
will.
so easy.
It's so easy. We're talking about R, okay? What numbers does R fit in between, by the way? Negative 1 and 1. It will never be less than negative 1, never be greater than 1, okay? I'm going to do my little negative 1, positive 1. I'm going to do my little scale here. Here is where 0 is. I'm going to put, this is like the bad range. Bad. Whoop, you can't see. You can't see. Bad range. This is like a good range. Or in other words, or a strong linear relationship.
Alright, then can I use that?
This guy is a good, yes, or a strong, I'm going to put negative linear relationship. Okay? We can put strong positive linear relationship. Strong positive, strong negative. Okay? Now, I'm not going to put a number here that's associated with where it turns from good to bad, right? Because sometimes it might depend on where it turns from good to bad. If I'm doing like a linear function that's representing like brain surgery, you better believe that a bad R would be 0.98, right? Because I want to make sure that that stuff is like really dead set on my line, right? If it has something to involve like something really important like that. Versus like farming, if we're trying to predict farming, maybe not all my dots need to necessarily be on my line. It's not going to kill anybody if I predict it differently than what it actually happens, right? Okay? But some scenarios, so that's just my example. Some scenarios, your R, a good R, like cuts off, and a bad R is like 0.98, okay? It all depends on the standard deviation, which we don't get really into in this section, okay? Thank God, okay? It depends on your standard deviation. We do that in stats, okay? So, good R, bad R, there's no one definite for sure. It changes from a good R to a bad R at this point. It just depends on per scenario, yeah? So this guy, R, it would be a positive relationship. This would be a negative relationship, no relationship. What do you think the R would be for this guy?
1.
It's not 1 exactly because they're not all in a straight line.
Greater than or equal to
0.998. This right here was a 0.96. Is this better or worse than that one? This
Oh,
one's
yeah.
0.96. That one looks better?
You're gonna hit more dots.
You think so?
Yeah.
Okay.
Alright,
So
sure,
point,
lines are
let's
gonna
say 0.98. Okay? I don't think it's necessary. I don't think it's exactly 0.99. We saw 0.9996 earlier in the first one that we graphed.
There was
0.9996. That was very, very, very close.
We have to.
What's this one going to be? What's the negative correlation?
Negative 0.98.
Probably negative 0.98.
They look kind of the exact opposite.
They kind of look the exact opposite. What would this one be?
0.
Pretty close to 0. Maybe like 0.1 or something, because it kind of does look like maybe some of the dots are going that direction. I don't know. So we'll give it a 0.1, but that's really bad. That's really bad. There's not a linear relationship between the two.
Can I
Okay?
read yours?
Yes. Does that answer all of your questions? Okay. Do the homework. I'll fix you, Brooklyn. Do the homework.
Fix me too.
Okay. I'll fix you. If you need to be fixed, I will fix you now. But I'm going to end the video. Do the homework.
Wait,